So the first emerging technology you should be prepared to adopt is the use of unmanned aerial vehicles, or UAVs, also known as unmanned aerial systems, UASs, to obtain existing conditions information about your infrastructure projects. I don't know if everybody else is experiencing this, but this is not the fourth time I've watched this video restart. Slight technical difficulty, apologize for that. So we'll let it run, hopefully it'll work out, but let's talk a little bit. So I'm sure that most of you have heard of them, but for those of you who haven't, UAVs, unmanned aerial vehicles, also referred to as unmanned aerial systems, are, for all intents and purposes, drones. UAVs are becoming increasingly popular as the emerging technology in many industries. The lower cost of the aircraft's cameras, software, coupled with the increased processing speed, cloud computing, and flight autonomy, has accelerated the adoption of UAVs to create an existing conditions model, or they're also used for site inspections during construction. LiDAR, or photogrammetry, is gathered through the use of high-definition scanners or cameras. They're mounted on a gimbal from the aircraft, and the UAVs can be remote controlled or have their flight plans automated. As seen in this video, once collected, the information is then stitched together using software such as Autodesk's Recap 360 Pro, which will produce point clouds or models of the information. This emerging technology is also becoming increasingly popular for developing planimetric features, volumetric surveys, pollution modeling, urban planning, coastline management, oil and gas exploration, and archaeological surveys necessary for federal environmental studies. This technology allows existing site conditions to be recorded and modeled in hours instead of days, and can produce more accurate data than traditional ground surveys. Remember, we want to produce faster, higher quality data. In my experience, surveyors are very particular about the topographic survey. With the advancements of BIM and the pressure to adopt BIM for civil infrastructure, skepticism abounds. Almost a year ago, a study was performed by Macintosh Perry Surveying and UKKO, a Canadian mining and surveying firm specializing in UAV aerial topographic survey. So the task was to compare the horizontal and the vertical accuracies of ground RTK GPS survey to UAV surveys. The field topographic survey resulted in acquiring 1,800 data points over a 100-acre site. Each point had an X, Y, and Z coordinate, and a digital terrain model was produced, and the field accuracies were observed to provide results between 3 and 8 centimeters in each of the 3 axes over 95% of the observation. The combined accuracies averaged between 5 and 6 centimeters, an acceptable level for subdivision development and drainage modeling. The same year, a fixed-wing UAV was used to conduct an aerial survey. On board the UAV was an 18-megapixel camera, allowing for 1 pixel to equal 3 centimeters on the ground when flown at a distance of less than 400 feet. The unit collected over 31 million points in 4 hours. But that also included the setup and the targeting of the ground control points. The actual flight time was actually less than an hour. All right, let's hope this video plays better than the last one did. All right. Start off a little bit slow on my end. That's okay. All right. So with UAVs conducting aerial LiDAR and photogrammetry surveys, the process and management of survey data will experience a major shift. The point clouds, meshes, and 3D solids will be referred to in lieu of returning to the site for additional field observation. The collected data will be edited and transformed to be used as terrain services for watershed analysis and site planning. This provides us with an opportunity to explore Autodesk's Recap 360 Pro. For those of you not familiar with Recap, this tool allows you to collect and process your point cloud and your UAV data into a single mesh model, as well as perform cleanup and geolocation. Recap Pro also allows users to obtain measurements based on accuracy of points, generate reports directly from the software, and also it gives you the ability to import ground control points and process photogrammetry obtained through UAVs. The collection of the data is of higher quality and is obtained faster, resulting in reduced project costs due to acquisitions and accuracies. Once the recap mesh is being completed, this data can be processed in Autodesk Memento. Memento allows users to perform mesh cleanup and optimization. Users will also have the ability to seal any holes or gaps there may be in the information, and the result is a much more optimized mesh with reduced polygon count, and all the materials at that point are then baked in to the final output. And next, that data can be brought into Autodesk InfoWorks for planning or Civil 3D for detailed design. Now, UAVs are also used for accurate geolocation of your model data, allowing efficient 3D mapping by utilizing ortho imageries to locate your model, and also to use the ortho model to verify accuracies in your model's elevational data. So this is done in collaboration with auto-geolocated GPS tagged photos. The result is a highly accurate, fully integrated, reality computed pipeline of intelligent information that can be used for design as well as existing conditions and analysis. See a slight delay. And Brittany, can you back up one slide, please?
Yes. This one, right?
Correct.
Okay.
All right, that one looks like it's loading okay. So an accurate view of the existing conditions is essential in planning and designing civil infrastructure projects. Without the tools to accelerate data collection and the processing workflow that runs parallel to the collection activities, time and money can be lost while waiting for a complete view of the existing conditions. Autodesk has the answer with a comprehensive software solution that helps you access and aggregate data, as well as collect, import, and process field survey data from a wider variety of sources. Connected workflows provide you with a way to build existing conditions models at a level of detail that is needed, and you can easily add to the model as the design progresses. With InfoWorks 360, you can build a 3D contextual model of the existing conditions in a matter of minutes. And the power and capabilities found in Model Builder allow you to take advantage of freely available data, including terrain, roads, rail, building, water features. There's no need to manually locate the sources anymore, and all the coordinate systems are managed automatically. You can then supplement the model by adding information from numerous other file types, such as CAD data, GIS data, point clouds, raster images, and file formats from other programs as well, such as Bentley, ESRI, and SketchUp. The result is a robust existing conditions model that establishes a strong foundation for project development. As the design progresses, you can take that existing conditions into Civil 3D and add the detail that are needed to complete the design. The model can even be used to help survey crews be more prepared to collect additional data needed in the field with a better visibility into the existing conditions before leaving the office. With Civil 3D, line work from survey data can be automatically generated and populated in the model. Accurate and up-to-date surface models can be generated from topography, and contours can be adjusted, and boundaries can be easily redrawn to more accurately represent the detailed surface. As work progresses, you can continue to add survey information to the model without the need of reworking the design. All related elements, including surface models, profiles, grading, corridor models, will all rebuild automatically, saving you valuable time on the project. With Autodesk and BIM for infrastructure, you can more easily access and aggregate data from a wide range of sources, giving you the ability to create accurate and intelligent existing conditions models faster, with less time spent reworking and reprocessing. Autodesk BIM for infrastructure helps your project team anticipate, assess, and act more confidently throughout the project lifecycle.